All right, we've taken a look at long division. What I want to look at now is called synthetic division. This only works when we are dividing by something in the form x minus c, some constant. It doesn't work if we're dividing by something that's a trinomial or something that has degree larger than 1. It's always got to be x minus a number or x plus a number, because x plus a number is the same as x minus a negative number. So let's look at an example, and I'll show you exactly how this works. Let's take 2x cubed minus 7x squared plus 5, and we'll divide it by x minus 3. So in this case, the value of c is 3. This is probably going to seem very weird if you've never done this before, but this is a great way to do division problems where we're dividing by x minus a constant, and it's a lot less work than long division. So we're going to set up an upside down division symbol. We're going to put the value of c on the left. In this case, c is 3. And then we're going to put the coefficients of the polynomial on the inside. In this case, 2, -7, 0, because there's no x term, so it's like plus 0x, and then 5. If we're ever missing a term between two different degrees, we've got to put in 0 for that. So this is how synthetic division works. It's almost going to seem like magic at first. So we're going to draw another line down here. And the first thing we're going to do is we're going to bring the leading coefficient, the first number, down. So 2 is going to go down there. Then we're going to multiply this number by our c. 2 times 3 is 6. And we're going to put that in the next column. Then we're going to add these numbers. -7 plus 6 is -1. And then we're going to multiply again. -1 times 3 gives us -3. And then we're going to add these. 0 plus -3 is -3. And then we're going to multiply again. -3 times 3 is -9. And then we add 5 plus 9 is -4. And the first numbers that we get, all but the last one, these give us the coefficients of the quotient. And then the one over here gives us the remainder. So what this means is that when we divide, we end up with 2x squared minus 1x, or minus x, and then minus 3. And then our remainder is going to be -4 over x minus 3. And of course, you could also write this 2x squared minus x minus 3 minus 4 over x minus 3. Either one of these work just fine for our answer. Does this seem a little bit weird? Probably. Is this less work than long division is? Absolutely. So whenever we're taking a polynomial and we're dividing by x minus a number, or even x plus a number, it's going to be easier to use synthetic division. You just have to remember that the value of c is going to be the opposite of whatever this term is. So because it's x minus 3, we've got a positive 3. If, for example, it was x plus 8, then we'd have a -8 over there. Now, synthetic division is very useful for us because we can use this when we're talking about the remainder theorem. The remainder theorem says the following. If a polynomial p of x is divided by the quantity x minus c, then the remainder is given by the value p of c. So if we take a polynomial and divide it by x minus c, the remainder is the value p of c. And this is particularly useful because when we do synthetic division, we are dividing by x minus c, and it's very easy to get the remainder. This took maybe 1.5 minutes at most. And what this tells us is that this is the function value if we evaluate it at this. So for example, we can use this to do a calculation. Let's calculate p of -2 when p of x equals 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. Now, if we wanted to do this problem before learning the remainder theorem and synthetic division, we would have to take -2 to the 5th power and to the 4th power and the 3rd power, and we'd have to multiply these by 3 and 5 and -4, and we'd have to add everything together. It would be a lot of work, and there's going to be so many negatives that it's very easy to make a mistake somewhere. But the remainder theorem tells us if we want to evaluate this polynomial, all we need to do is take it and divide it by x minus c, in this case x minus -2. And when we have synthetic division, that ends up being very simple. Let's set up our synthetic division. We are going to divide this polynomial, which has coefficients 3, 5, -4, 0, 0 because there's no x squared term, 7 and 3, and the thing that we're evaluating this at is -2, so we're going to put a -2 there, and watch how much easier this is than actually substituting in -2 4 times and raising it to all these powers and everything. So we bring the 3 down here. 3 times -2 is -6. 5 minus 6 is -1. -1 times -2 is +2. -4 plus 2 is -2. -2 times -2 is 4. 0 plus 4 is 4. 4 times -2 is -8. 7 minus 8 is -1. -2 times -1 is +2. And 3 plus 2 is 5. And this is the remainder when we take this polynomial and divide it by x minus -2 or x plus 2. But the remainder theorem tells us that this is the function value, so we know that p of -2 is equal to 5. This is a particularly useful way for us to evaluate a polynomial function at a certain number. We just need to use synthetic division, putting the number here, and we get our answer out at the end. This is something that we're going to be using moving forward in a couple of different situations, so it's really important to get used to synthetic division and understand how it can be used to evaluate a polynomial at a given number.